Okay, sorry about that. I was just about to make the mistake even after me saying it. So note that is a sphere, so that's not the volume of the sphere. You have to divide it by 2. That's why the marking scheme says 18 pi, because it is 18 pi. So that's worth 5. Sorry now, while I'm here, while I was on my break there, I went and got a scheme for this. So A, B, and C are marked together and they're worth 15 marks. So over here, you get a low partial, which is 6 marks for work of merit in one part. So if you got something right in any part. If you get one part fully correct, you get 10 marks. And if you get work of merit in 2 parts, and then if you get 2 parts fully correct, you get 12, and then 15 for all 3 parts correct. And then for this one, it's 10 marks in total. So low partial, which is 3 marks for any work of merit. So if you manage to change 49 into 7 squared, that would be work of merit. High partial for getting as far as this line here. So 2x equals 2 plus x. And then fully correct will get you 10 marks. Okay, so I'm back here now. So work out the volume of the cylinder is 36 pi. Okay, work out h, the height of the cylinder. Okay, so the volume of the cylinder. So I'm now moving down to cylinder and I'm taking the volume. So again, making sure you're choosing the right shape and the right formula for that shape. So it says we know the volume. The volume is 36 pi. Then we have pi, or I think was 3. Yep, because it said they were the same. And then h. Yeah. So 36 pi equals, I can do this bit here. So that is 9 pi. And then that's by h. And if I want to isolate h, I need to divide by 9 pi. Dividing by 9 pi on the right hand side will cancel the other 9 pi and will isolate the h. And dividing by 9 pi on the left balances that out, and then that gives me 4 for h. So 4 meters, but you don't. Actually, I must double check that, but I'm pretty sure you don't need the units. Yeah, no, you don't need the units. So 4 for 10 marks. Now, this one I think there might have been an issue with, because I think it might require some geometry that we haven't done this year. Now, you did it at junior cert, but like it wasn't what we said was going to be on it. So the diagram on the diagram on the right below, okay, shows part of the base of the lighthouse, not to scale. It's in the shape of a cone of radius 7.5 meters, from which the top part has been removed, leaving a horizontal circle of radius 3 meters. The height of the cone before the top part is removed is 47. Work out the size of the angle at the base of the cone marked A in the diagram above. Okay, that's trigonometry. So there's probably not any point in me doing it. So we weren't assessing trigonometry because you haven't done it since junior certs. So that one is not going to count. Find the distance marked K. That one is synthetic geometry. It is similar triangles, I think. I'll check the scheme now, which we also haven't done. Assume that the Fastnet lighthouse can be seen from anywhere within a circle of radius 50 kilometers. Work out the area of the circle within which the Fastnet light. Okay, so this we can do. Sorry, I'll check the scheme for those other ones in a second. So work out the area of the circle. Right, so back into the formula and tables book. This time we're area. We're looking for circle. So first I'm choosing the right shape. So it's a circle. I'll throw this out here. And then they want the area. So it's not the top one, it's the bottom one. Okay, I'm going to make that a bit smaller. So that is, it doesn't say anything about pi. So do you remember I was saying just use the button on your calculator if they don't tell you? And then it says that the radius is 50 kilometers. So I'll put 50 in here, and then the formula tells me to square it. So pi multiplied by 50 squared equals, and I'm pressing SD, I'm getting 7853.98, and the number continues. It does say to the nearest kilometer, which means I don't want a decimal point. So we ask ourselves, is the 9 strong enough to push this up? It is. So it's going to be 7854 is the area of the circle. I'm just going to go back and check the scheme for all this. Yeah, so that one was tan. So that's 5 marks that we're not going to. And yes, that one is similar triangles. You can do it with trigonometry as well. So that's another 5 marks. We'll take off this question. So we just won't look at it basically. It's so hard sometimes when you're choosing questions. You try to make sure that obviously that looked like an area and volume question and just didn't notice that trigonometry was in there. Yeah, so 7854 for that one is doable and correct and worth 5 marks. The last one then. So 50 kilometers is 27 nautical miles. Use this to work out how many kilometers are in 1 nautical mile. Okay, so this is just like a proportion. We did loads of when we were doing VAT and all that financial maths. So 50 kilometers equals 27 nautical miles, and we're looking for 1 nautical mile. You work on the side that's complete, which is this side. Check if there's a 1 there already, which there is. So we don't need to add a 1 because there is a 1. So you just ask yourself, how do I get from 27 to 1? So to get from 27 to 1, we divide by 27. And then once you've decided on the maths, you bring it over to the other side. So we divide by 27. So 50 divided by 27 is, hang on, so it's 1 point. Now I had to, there's a recurring decimal in this, as in there's dots over some of the numbers. So I had to press the SD button twice. But when I do that, I get 851 is what my calculator says. And then here it says 4 significant figures. So again, significant figures start at the very beginning, unless it's a 0. So my first significant figure is 1. My second one is 8. My third one is 5. And my fourth one is 1. And that's where I'm going to stop. We look to the next number and decide if it's strong enough to push up the previous one. 8 is strong enough because it's 5 or greater, so it will push it up. So we get 1.852 as your answer to that one. And that is also doable and worth 10 marks. Right, so that has changed now. So 10 and 5 and 10 and 5. What's that, 15 and 15? 30? Hopefully this says 40. Oh, why does it say 50? Okay, let me have a look. Question 4 says 50. So we have 5 and 10. It's 20. Okay, not sure. So it is now worth 30 anyway. So question 4 is worth 30. Right, so then question 5. Right, we're nearly there. The prices of houses in a particular area have been increased over a number of years. A house is valued at 240,000 at the start of 2019. By the start of 2020, the price of the house has increased by 8%. Can I just calculate that before I read any more? No. So it's increased by 8%. So if I get 8% of 240,000, I get 19,200, and then increase it by that much. So just add it on. So plus 240,000 is 259,200, right? So that's at the start of, sorry, I'm just going to get a red line. Oh, it is not red. That's fine. Okay. By the start of 2021, the price of the house has increased by a further 9% based on the 2020 price. Okay,